once you've done this actual manufacturing with wafer space, what happens then? Do you like yeah, I guess yeah, what happens then?
Then I get to test and verify 1,000 chips.
Right. Do you have any inkling of an idea how long that would take?
Um, no. Basically, I need to figure out how to actually verify silicon,
Mhm,
which is basically figuring out how to create a test bench where then I would be able to plug a chip in and then push a button, and then it would have to run through a various set of tests, like being able to load a bit stream on, which is the program of an FPGA, uh, then try to see what happens when I drop the voltage all of a sudden, or what if I increase the voltage a ton, or
mhm,
just all these magic things that usually happens with chips in the world.
mhm, mhm. Do you have any thoughts on how you're going to handle this, or is this something that's a future you problem?
Both. The one of the ways I've had is if you're familiar with fuzzing in software, that is basically you do a bunch of randomization and then see what happens when code gets random values and see if that breaks.
Mhm, mhm.
And so my idea was basically have a bit stream that, or rather a program that gets loaded on that has a amount of randomization to it that is predictable to then where I can derive the output from the randomization and then see whether or not the chip outputs the values I want.
Mhm.
And so then run that for maybe an hour and hopefully things are good. The less the more predictable ones would be just be like bring up voltage, bring down voltage, check what the chip is doing, maybe have like something that just counts numbers to infinity
Mhm.
and then see like what happens to that when I drop the voltage or when I increase the voltage.
Right. And hopefully you what do you know what like a good yield would be?
Um about 80%. So that'd be like 800 chips.
Mhm.
It is hard to say because this is the first this would be the first batch. This would be like the first time this design has ever been put into hardware.
Mhm.
And so it'd be hard to kind of figure out like what kind of yield I can get. But since this is using a third yield process node that is like very not really predictable, but it's like the limitations of the design has been known for so long, and that because it is by nowadays today's standards, it is a boring process node. No one wants to mess with it because there are shiny new things like Intel 18A and like TSMC trying to do 2 nanometer or whatever they're doing nowadays.
Mhm. Mhm. Okay. So once you've done the testing, once you've done you've got your chips, I guess what happens with them? What do you do with your theoretical 80% yield?
Then I'll be crowdfunding to get development boards out, and then people should be able to buy one of these chip or boards with a chip on it,
Mhm.
and a dev board would probably just have like a bunch of random things like headers for plugging stuff in, buttons, lights, jumpers, just usual things, kind of like what you'd see on a regular FPGA board, or kind of like what you might see on some sort of like carrier board for like a Raspberry Pi or something. It's just enough that if someone wants to play around, they have enough fun little things to try to do something with.
So actually, that's a good question. You earlier on you mentioned how a lot of the tooling around FPGAs for the ones that have traditionally existed has been proprietary. How would somebody, I guess, mess with this FPGA? Like, what would they need to do with it?
All they would need is the open source toolchain that everyone else uses. Um, I have Nix stuff there that makes it easy. So you just pull in Yosis, you pull in NextPNR, and then all you need is just my fancy little Rust program that just backs that into a binary format for the chip.
Mm-hmm.
And it's literally just a Nix flake. So it is easy to get working. There's also there's Docker containers, there's stuff for apt. So using this not on NixOS is possible.
Mm-hmm. So now this has been like having some discussion. What has been the initial response like?
Very positive.
Mm-hmm.
At first I teased a little bit on Twitter, like a week or two prior, and then I was kind of like, well, it seems like there's interest. I put it out, and then like I was getting Twitter notifications for like a week straight. And then I look on GitHub, and now it's at 300 stars.
Mm-hmm. Okay. I guess obviously that's like general interest, but like what has been the the more hey, I'm interested in actually having one of these interests like?
Oh, I've seen a decent amount of people that the want this in some form. Um, I made a couple GitHub discussions with polls, and it seems like people want this thing. There could be more interest, especially when I do the Kickstarter and when I actually have the chips in my hands.
Mm-hmm. Right, that's obviously like a big thing, right? It's one thing to say, hey, here's this thing I'm working on. It's still in testing. We don't actually have production yet. Once it actually exists as a real thing that you can demonstrate functions, that changes things.
Yeah, especially if I can bring this to like conferences, then I can show in person this thing does the thing. You can get it.
Mm-hmm.